Hi guys, today we're looking at the derivation of trigonometric formulas. With any proof, always consider the tools that you have available. So you know the sine rule, the cosine rule, the area of a triangle formula, the distance formula, and any previous proof that you have already used. Formula 1, prove cos squared a plus sine squared a equals 1. Okay, so the first thing we're going to do is draw a point in our first quadrant where cos A sine A stands. As cos A is the x coordinate and sine A is the y coordinate, both of these are positive, so we know this point is in our first quadrant. We know that A is the angle to get to this point, and I know that the radius is 1. Our proof. Cos A sine A is a point on the unit circle. Hence, the distance from cos A sine A to 0, 0 is 1 unit. Therefore, using the distance formula, we know that the square root of cos A minus 0 squared plus sine A minus 0 squared equals 1. Squaring both sides gives us cos A minus 0 squared plus sine A minus 0 squared equals 1. This gives us cos squared A plus sine squared A equals 1. Please pause the video and take down this proof. Hi guys, so let's look at proving formula 2, the sine formula. A over sine A equals B over sine B equals C over sine C. This is found on page 16 of your formula and tables booklet. The first thing we're going to do is draw a triangle ABC with lengths A, B and C. We know that a half AC sine B equals a half AB sine C, as this is our area formula for a triangle. We now divide both sides by a half ABC, and we're left with sine B over B equals sine C over C. Flipping this gives us B over sine B equals C over sine C. And similarly, A over sine A will equal B over sine B. Therefore, A over sine A equals B over sine B, which equals C over sine C. Please pause the video and take down this proof. Let's look at formula 3, the cosine formula. A squared is equal to B squared plus C squared minus 2BC cos of A. Our proof. Let's draw our diagram. And we're going to increase the unit circle by a factor of B. Therefore, the radius of our unit circle is now B, and any point on the circle can be described as B cos A, B sine A, where A is the angle between the x-axis and the radius to a point. Based on the coordinate geometry distance formula, the distance between the vertices containing angles B and C is the square root of x2 minus x1 squared plus y2 minus y1 squared. Substituting our points in gives us A equals the square root of B cos A minus C squared plus B sine A minus 0 squared. Squaring both sides, we get A squared is equal to B squared cos squared A minus 2BC cos A plus C squared plus B squared sine squared A. Factorising this, we can write it as A squared equals B squared cos squared A plus sine squared A plus C squared minus 2BC cos A. But we know that cos squared A plus sine squared A equals 1, and substituting this into our formula gives us A squared equals B squared plus C squared minus 2BC cos A. Please pause the video and take down this proof.